How do you solve, graph, and interpret inequalities? We're going to look at a couple different examples in this. So first we start with just reminding ourselves of algebraic principles. If I have an equation 2x plus 8, I can do inverse operations to both sides and end up with x equals 5. Working my way through that. Pause this video and kind of analyze this work if you're a little confused by how I got there. We're going to then move on to an inequality. So you've seen this in the past where you had an inequality of x is greater than 3. You're able to put that on the number line. Again, your open circle is because it's greater than, 3 is not included, and then you point to everything to the right of 3 on that number line. If you have an inequality such as x is less than or equal to 6, because you have the equal, it can equal 6, it's closed, so you fill in the circle, and you put everything to the left because x is less than 6. So this is how you would graph them on a number line. Sometimes we have inequalities that are written like a linear equation with one variable in them, and they look like this. This is the same problem we started with. It's that same 2x plus 8 equals 18, but now instead of an equal sign, I have is less than. I use the same algebraic principles to simplify this, where I will subtract 8 from both sides, divide by 2, and I end up with x is less than 5. Instead of x equals 5, x is less than 5. Note the inequality symbol stays the same all the way through, and there is one case, well, kind of two cases, one exception where we change the inequality symbol, but in this case, it's going to say less than. So I put that on a number line, I put 5, it's an open circle, because I'm open, do not equal 5, and everything to the left less than. All right. Now, if I just had negative 3 is less than 9, this is a true statement. But if I were to use algebraic principles and divide both sides by a negative number, such as negative 3, negative 3 divided by negative 3 is 1, and 9 divided by negative 3 is negative 3. Well, 1 is not less than negative 3. That's false. So whenever we divide or multiply by a negative value, you have to flip the sign because 1 is greater than negative 3. So this is true. So again, anytime we multiply or divide by a negative value, when we're using inequalities, we flip the inequality symbol. Even if it's less than or equal to, we still flip it, and the equal to stays there. We just flip it so it points the other way. All right. So now we have this problem, right, with two variables. 4x plus y is less than 24. So in order to work with this, what you want to do is put it into, you want to kind of pretend this is an equal sign and put it into a situation where you somewhat have like a linear equation, y equals mx plus b. To do that, I subtracted 4x from both sides, so I ended up with y is less than negative 4x, because I had 24x minus 4x, negative 4x plus 24. I now have my y-intercept and a slope of negative 4. So I kind of sketched a graph here. It's not a perfect graph, but I labeled this as 0.024 is up here on the y-axis, and I drew a pretty steep downward decreasing line going from there. To illustrate this on a graph, though, there's a couple things we need to remember. This line is actually disconnected. It's a dotted line. The reason it's dotted is because I'm less than, but I don't include the line. The line is not included, so I dotted line. And then everything, since it's less than, everything less than that line to the left or underneath is shaded. So I shade all of that in. There's a lot of graph shading when graphing these. So first I put it into y equals mx plus b. So I have my slope-intercept form, I graph it, and I put it there. All right. This is like a real-world example, sort of. Say you have a cell phone that you know is going to cost at least $600, right? But you already have 150 saved. So here's my 150 I already have saved. Here's my 600, and I can have a I'm going to get a job and I make $50 a week. So $50 times x, the number of weeks, plus the 150 I already have saved, has to be greater than 600. Once it's greater than or equal to 600, because my phone's going to cost at least $600, the new one, a new phone. Now, I want to figure out how long it would take to get this. So what I want to do is I set this to greater than or equal to 600. I subtract 150 from both sides, and then I divide both sides by 50 to isolate my variable, and I have x is greater than or equal to 9. Now that x is greater than or equal to 9, I can actually now, I don't have to graph it on a number line. I can graph it on a coordinate grid because I can graph the line x equals 9. And so I go over here to 9, and it's just be a straight vertical line at x coordinate 9, but it's greater than or equal to. So I have it a solid line. I don't dot the line. It's solid because it includes 9, and it's everything greater. So I shade everything to the right of that line. So I draw that line up and down, shade everything to the right. And again, these are just some quick examples of how do you solve graph and interpret inequalities. So I guess the interpretation here would be that anything more than 9 weeks would get me enough money to have over $600.